Hi guys, and welcome to another video. Today we're going to be looking at functions, finding the equation of a parabola given the x-intercepts. And the question that we're going to be looking at came out in the KZN June 2019 paper. The question reads as follows. It says the sketch below shows the graphs of y equals to k to the x plus t and y equals to ax squared plus bx plus c. So we're only going to be concentrating on the parabola in today's video lesson. It says the x-intercepts of h are 0 and 0 and 0 and 4. Well, this is supposed to be 4 and 0, so we'll correct that. And q is 1 and negative 3. Is a point on h. The horizontal line through P, the turning point of h, is the asymptote of g. The x-intercept of g lies on the axis of symmetry of h. Now, the only thing that we are concerned with in this particular question is finding the equation of a parabola given the x-intercepts. And I'll cover the rest of the concepts in future videos. So the x-intercept here is, as we can see, 0 and 0 if you write the full coordinate, and here it's 4 and 0. Okay, remember at your x-intercept, y is equal to 0. We're looking for is a point which is given on our graph, and that point is q, 1 and negative 3. And the question says, show that a is equal to 1 and b is equal to negative 4. So let's look at that very carefully. The equation that you have to use here is y equals to a into x minus x1, x minus x2. And this equation is called the intercept form, quadratic equation. Now we are going to substitute and solve for a. Now what are we going to substitute? Well, x1 and x2 are the roots of your parabola. So we have x1 and x2. So x1 is 0, x2 is equal to 4, and those are the roots of our parabola, the x-intercepts. And we have the point which is given on our parabola, which is q1 and negative 3. So q1 and minus 3. So that's all we need, our x-intercepts and a point on the parabola, and now we can find the equation with ease. So let's look at that. So therefore, the point q gives us the x and the y value to substitute into our equation. x1 is 0, x2 is 4. So let's substitute. Negative 3 equals to a into my x value is 1 and x1 is equal to 0, so it will be 1 minus 0. My x value is equal to 1, so that will be 1, and my second root is 4, so therefore that will be minus 4. Now let us solve for a. So therefore we have minus 3 equals to a times 1 minus 0 is 1, and 1 minus 4 is minus 3. Therefore, we'll have minus 3 equals to minus 3a. Solving for a, therefore a equals to 1. Now, the next part of our solution would be as follows. We are going to substitute a and the roots into the formula y equals to a into x minus x1, x minus x2, which would give us 1 into x minus 0, x minus 4. Remember, x1 is 0 and x2 is 4, which is equal to 1 into x. X minus 0 is x, and we're left with x minus 4. So let us open our brackets, 1 and 2. So we got x times x is x squared minus 4x. Now we'll take 1 into the bracket. Remember, part mass, you have to open the brackets first before you can do any multiplication. So therefore you'll be left with x squared minus 4x. So therefore our function h of x, remember h of x, the function is h, is it here? We call it by its correct name, is equal to x squared minus 4x. So we can conclude that a equals to 1 and b equals to negative 4. I will cover finding the equation of a parabola given the turning point and one other point in another video. Learners, if you haven't subscribed already, subscribe to JL Maths, like my Facebook page, Justin Lazarus Mathematics, and also you can check out all the videos on jlmaths.com. And I'll catch you in the next video.